So in today's class, my plan is to start trigonometry. In trigonometry, the first thing that we are going to discuss is a concept of Pythagoras theorem. Okay, so trigonometry is the topic. The first concept that I want to discuss with you is Pythagoras theorem. Now, this theorem states that for a right angle triangle, for a right angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Now, cutting the long story short, if you have a right angle triangle, when do we say a triangle to be right angle? If one of the angle is 90 degree. So if triangle ABC is a right angle triangle, the side opposite to 90-degree angle is the longest side and is known as the hypotenuse. And if this is the angle that we are considering, then the side AB is going to be the adjacent side, and the side opposite to the given angle is going to be the opposite side. And this is the hypotenuse. Now, Pythagoras theorem states that hypotenuse square, the square of the longest side in a right angle triangle, the hypotenuse squared, is equal to the sum of the square of opposite and the adjacent side. That's only for the right angle triangle. All right. So if you have a question, let's do a question and see if you can apply this. This xy is a chord in a circle. O is the center. OX is the radius. And there's a line that extends from O till the circumference and intersects the circumference at P, and it passes through, it cuts the chord XY at N. So this line OP that is known as the perpendicular bisector. This line OP is the perpendicular bisector of this chord XY, meaning it is going to divide the chord into two equal halves, and this line is going to be at 90 degree. So the perpendicular bisector of chord XY cuts XY at N and the circle at P. If XY key length is 16 centimeter and NP is 2 centimeter, the question says calculate the radius of the circle. Okay, so XY is a chord that has a length of 16. The perpendicular bisector is going to bisect this chord and divide the chords into two halves. So the chord length, this xn is going to be 8 and this ny is going to be 8. Together xy had a value of 16. Now would you agree that OX is the radius? Would you agree that the length OX is the radius of the circle?
Yes.
And would you agree that OP is also the radius? So OP is equals to
Yes.
OX is the radius, and we don't know this value, so I'm going to say R. Okay, and XN, the chord length came out to be 8 centimeter. Now, if I consider the right angle triangle and use the knowledge of a right angle triangle to solve for the radius, I need to find this length. ONX is a right angle triangle. If I ask you what is this length going to be, NP is given to me as 2 centimeter. Would you agree that ON is nothing but OP minus 2? The value of ON
Yes.
is OP minus 2. So OP is the radius, so it comes out to be R minus 2. Now consider the triangle, right angle triangle ONX, in which ON is R minus 2 and XN is 8 and OX is R itself. So using Pythagoras theorem, you can calculate the value of R. You're going to come up with the equation OX square is equal to ON square plus NX square or XN square. So R square is equal to R minus 2 whole square plus 8 square. You're going to simplify this and get R square minus 4R plus 4 plus 64 equals to R square. R square can be simplified. 4R comes out to be 68. So R comes out to be 68 upon 4, that is 17 centimeter. This is one of the application of Pythagoras theorem. So you were able to calculate the radius. Okay. Now the next
Okay.
thing that we can now the next thing that we can discuss over here is the trigonometric ratios of an acute angle. Trigonometric ratios of acute angle. If I have a right angle triangle, triangle ACB, let's say, and angle C is the 90-degree angle. So the side opposite to the 90-degree angle is the largest side, that is called hypotenuse in a right angle triangle. If this is the angle theta, this is some angle which right now I don't know, but I'm going to consider it to be theta. So the side that has theta and 90-degree along with it is known as the adjacent side, and the side opposite to the given angle theta is known as the opposite side. Now there are three trigonometric ratios. Okay, there are three trigonometric ratios: sine. Now sine is a trigonometric ratio. You always find sine of an angle. So this time sine theta, cos theta, tan, tangent theta. This is read as sine of angle theta, cosine of angle theta, and tangent of angle theta. But we, for short form, we can write sine theta, cos theta, tan theta. Now sine theta is the ratio of the opposite side over the hypotenuse, meaning this side upon this.
सॉरी
Okay,
सर्वर डिस्कनेक्ट हो गया था.
ठीक है, कोई मसला नहीं. Cos theta is the ratio of adjacent upon hypotenuse, and tan theta is the ratio of opposite over adjacent. So these are the three trigonometric ratios. If Do you know all these trigonometric ratios by heart?
Yes.
Okay. You can use also you can use a statement, that a common statement to remember this. some opposite is also known as the
People,
perpendicular. Yeah. And
some
adjacent
people
is
have,
also known as the base. Some people have curly brown hair, 10 people black. Okay. Okay.
yes,
ठीक है. So these are the three trigonometric ratios. Acha, if I give you an example, so let's say the adjacent side is 3 centimeter, opposite side is 4 centimeter. What is hypotenuse going to come out as? Apply Pythagoras theorem and give me the value of the hypotenuse. What is the value of hypotenuse coming out?
4.12.
3 square plus 4 square square root.
नहीं, ओ सर मैंने गलत किया, 1 मिनट. 5.
Exactly, 5 centimeter. Now, applying the trigonometric ratios for sine theta, the ratio is going to be sine theta is going to be the ratio of opposite over hypotenuse. So, what is going to be the ratio? Would you agree? It's going to be 4 over 5. This is the opposite side. This is the
Yes.
hypotenuse side.
Hmm.
Now,
Yes.
cos theta is going to be the ratio of
3/5.
3 upon 5, and tan theta is going to be the ratio of
4/3.
4 upon 3. Okay, very good. Now, can you express angle B in terms of theta? What is this angle going to be in terms of theta? If this angle is 90 degree and this angle is theta, what is this angle going to be? Angle B plus theta plus 90 should be equal to 180 degree. So angle B should be 180 minus 90, that is going to be 90 minus theta. Okay, so this angle B should be 90 minus theta. ठीक है?
जी सर.
So if I consider this angle B as the angle now, and if I want to find the trigonometric ratios of angle B, so what is sine of angle B is going to be? Now angle B is 90 minus theta. So what is sine of angle B going to be? When you have this angle as sine, so hypotenuse is going to remain same, but this angle, but the side opposite to this angle is going to be the opposite side. So I'm going to call AC as my opposite side now. And this angle and 90 degree lie on this line. So this line is going to be your base या adjacent. ठीक है? Base भी कह सकते हैं, adjacent भी कह सकते हैं. So if the angle in a right angle triangle is changed, the opposite and the adjacent are swapped. आप देख सकते हो ये side opposite होगी and this is going to be your adjacent side. So with respect to this angle, sine of angle B is going to be opposite upon sin theta किसका रेशियो होता है? sin theta वैसे
Perpendicular upon
perpendicular
hypotenuse.
perpendicular over hypotenuse, तो perpendicular side ये हो जाएगी आपकी, ठीक है, क्योंकि इसके opposite है, और hypotenuse 5 हो जाएगा. So the answer is going to be 3 upon 5. Is that correct?
Yes.
What is cos of 90 minus theta going to be?
Four upon 5.
4 upon 5. And tan of 90 minus theta?
3/4.
3 upon 4. Very good. So these were the trigonometric ratios for your acute angle. And we can see that in a right angle triangle, if it's a right angle triangle, then you are going to have these two angles as an acute. Now so let's do some questions on this. I'm going to draw two figures and I want you to find the unknown values. Okay. So this is a diagram and we need to find the unknown values of x and y. So you're always going to identify the right angle triangle first to begin with. So in the triangle ADC, you have the hypotenuse length, you have one of the angle, and you have length as x that is opposite to this given angle 30 degree. So can I call this side AD perpendicular or the opposite side?
Yes. Yes.
And so which trigonometric ratio deals with the opposite side and the hypotenuse?
Sine.
Sine.
Sine theta.
Great. So sine of 30 degrees should be equal to the perpendicular upon hypotenuse. So from here, to find the value of x, you have to multiply 13 times sine of 30. Do not, sometime if you are using an older version of a calculator, plugging sine 30 multiplied by 13 in the calculator might give you the wrong answer. So this is a better way of writing it, 13 times sine of 30 degree. So what is 13 times sine of 30?
6.5.
6.5. Sine 30 half hota hai, this is going to be 6.5 centimeter. Now, how do you suggest on finding the value of y? If I know the value of x, if you know that BDC is a straight line, would you consider this to be a right angle triangle too? Angle ADB would be a right angle triangle,
Yes.
yes? So
Yes.
considering ADB as a right angle triangle, you have the length of AB as 10. You just found the length of AD and you are asked to find the length of BD. Would you be using Pythagoras theorem over here?
Yes.
So AB square is going to be equal to x square plus y square. AB is 10, x came out to be 6.5 and y is unknown. So please calculate this for me. What is y value coming out? 10 square minus 6.5 square square root. Give your answer to three significant
3.5.
figures. Sorry?
सर कैलकुलेट कर रही हूँ अभी.
Okay.
7.6.
7.6. Okay. So in three significant figures, it should be 7.60.
Yes, 7.60.
Okay. I'm drawing this next figure over here. You can then do this. Let's solve this. So in this triangle, first consider the right angle triangle that you can see over here. You don't have angle y as well, and you need to find angle, the length x as well. So first let us find the length x. You see this angle f is a 90-degree angle. So your triangle EFH is going to be a right angle triangle. You know the length of FH, and you know this entire length is 8. So now you can use Pythagoras theorem. 17 square is going to be equal to x square plus 8 square, and you can find the value of x from here. What is the value of x coming? 17 square minus 8 square, square root is coming out to be 225. Square root of 225, that is 15. And obviously the length x should be less than 17, right? Then we need to find this angle y. So if I consider the triangle EFG, which is a right angle triangle, and I want to find angle y, I am going to see which sides are given to me. The opposite side is now known to me as 15, and the adjacent side is 4. Which angle deals with opposite side and the adjacent side? Is it sine, cos, or tan?
Sine.
It's tan. Tan of angle y is equal to perpendicular upon base, that is 15 upon 4. For angle y, you're going to take out tan inverse of 15 upon 4. Calculate this out.
0.7.
So taking out tan inverse of 15 upon 4 in your calculator, you're going to get 75.7.
7. 7. Oh, 1. Sorry. 75.1.
75.1. And you're going to, in your O-level exam, you're going to give your answers in angles to 1 decimal place. Okay? This is going to be rounded up to 1 decimal place. The lengths are going to be in three significant figures, and the angle in degrees are going to be in 1 decimal place. Okay, good. Now let's see trigonometric ratios of obtuse angle. Trig ratios of obtuse angle. Now we know what an obtuse angle is. It's an angle that is greater than 90 and less than 180 degree. To find the trig ratio of an obtuse angle, the trigonometric ratio of an obtuse angle basically can be expressed in terms of the adjacent acute angle that lies on the same straight line. What do I mean by this? If you have this right angle triangle with you, the acute angle is this theta, and the equivalent obtuse angle is going to lie outside this, when you extend the bottom line, this is going to be the obtuse angle, and it is going to be equal to 180 minus theta, because the sum of these two angles must be 180. Sum of the angles of a straight line is 180 degree. तो अगर ये एंगल थीटा है तो दूसरा एंगल is going to come out as 180 minus theta, and we are talking about a right angle triangle. Okay, so I'm just going to name that this is, let's say this length is A, this length is C, and this length is B. So if the question says find sine of the obtuse angle. Now obtuse angle in our case is going to be 180 minus theta, or cos of 180 minus theta, or tan of 180 minus theta. So basically the trigonometric ratio of the obtuse angle can be expressed as a trigonometric ratio of an acute angle with some adjustment. So you use the right angle triangle first to find the trigonometric ratio of an acute angle, and then for obtuse angle you are going to change the signs of sine, cos, and tan. So what I mean is that if okay, you need to know this, that sine of 180 minus theta is same as sine of theta. This there is no sign change for sine ratio, because sine of an acute angle is always going to be equal to sine of an obtuse angle. You can check this in your calculator as well. Let's say theta is 30 degree. So if I calculate sine of 180 minus 30, it should come out to be equal to sine of 30 degree. So sine of 180 minus 30 is 150, and sine of 30, both trigonometric ratio will have the same value of 1 upon 2. Okay, so one thing that you need to remember is that sine of an obtuse angle is going to be equal to sine of an acute angle. Sine of 180 minus theta is going to be equal to sine of theta. So if I ask you that I calculate sine of 180 minus theta, the first thing that you're going to do is you're going to convert this into its equivalent trig ratio for acute angle, and then using your right angle triangle, find that so sine theta from this diagram is going to be the ratio of A upon C. So for this example, this is going to be equal to A upon C. Cos of 180 minus theta. Now cos of 180 minus theta, the cos of an obtuse angle and tangent of an obtuse angle are equal to negative of cos of a positive angle. So cos of an obtuse angle is going to be negative of cos of an acute angle, and tangent of an obtuse angle, that is 180 minus theta, is equal to negative of tan of an acute angle. So in this case, if using this diagram, if I ask you to find cos of 180 minus theta, you're going to remember this, that cos of 180 minus theta is negative cos theta is equal to negative of the acute angle, and cos theta, you're going to evaluate cos theta from this right angle. Cos theta kya aayega? It's going to be the ratio of adjacent upon hypotenuse. So this is going to come out as minus b upon c. And tangent of 180 minus theta is going to be equal to minus tan theta, and that is going to be equal to minus a upon b from our diagram. Is this making sense?
Yes, sir, understood.
Okay. We have been given a triangle ABC and ABD. This length is 12, this length is 13 units. So using this figure and without using the calculator, okay, without using the calculator, we need to find the length of BC. The second part is to find the sine of angle AC. cos of angle ACD, and tan of angle ACD. So let's start with the working for the first part. BC की लेंथ कैसे फाइंड करेंगे आप? The length of BC is going to be equal to, would you use this right angle triangle?
Yes.
And how am I supposed to find the length of BC now?
सर साइन का रेशियो लगाएंगे.
बट क्यों? एंगल तो नहीं गिवन अभी. मुझे BC की लेंथ फाइंड करनी है. मेरे पास इस राइट एंगल ट्रायंगल में हाइपोटेनस भी अवेलेबल है और ऑपोजिट साइड भी अवेलेबल है. तो मैं ये
पाइथागोरस थ्योरम लगाएंगे.
पाइथागोरस थ्योरम अप्लाई करेंगे आप. So 13 square is going to be equal to 12 square plus BC square, and use this Pythagoras theorem to calculate the length of BC. 13 square is 169 minus 144. Square root of 169 minus 144 is 25. Square root of 25 should give you 5. Okay. Now the next part is find sine of angle ACB. Sine of ACB. ACB is this acute angle. So I don't need to, so the ratio is going to be simple. Sine theta ratio is going to be, sine of this angle is going to be equal to what ratio? What is going to be the value of this ratio if I'm considering this angle, this acute angle?
-180 minus theta.
No, understand the question. You need to find sine, the ratio of sine of angle ACB. ACB is the acute angle inside the right angle triangle. इस एंगल के रिस्पेक्ट से इसका साइन थीटा की वैल्यू ढूंढनी है. So sine of angle ACB, sine theta is a ratio of what? Opposite over hypotenuse. So with respect to this angle, this is the opposite, यानी कि perpendicular वाली side, and that's your hypotenuse. So the ratio is nothing but 12 upon 13. Are you clear till here?
Yes.
पक्की बात है?
जी.
Okay. Now in the next part, they are asking you to find the ratio of cos of angle ACD, cosine of angle ACD. Angle ACD is this angle, and we can see in the diagram that it's an obtuse angle. Now, cos of an obtuse angle is going to be equal to negative cos of an acute angle. And what was the acute angle of ACD? If ACD is the obtuse angle, what is the acute angle? What is the adjacent acute angle? लेटर क्या होगा? ये ACD was the obtuse angle, ठीक है? यहाँ पे this angle is obtuse angle. तो ये वाला एंगल क्या होगा? इसका नाम क्या होगा इस एंगल का? ACB, right? If this is your obtuse angle, so इसका adjacent acute angle is going to be ACB. Are you clear till here?
Yes.
Okay, so cos of ACB, now you just have to use this angle, and इसके respect से you need to find cosine of this angle. Now we know BC की length came out to be 5 centimeter. Cos theta is the ratio of base upon hypotenuse. So this is going to be negative of cos ACB is going to come out as base upon hypotenuse, जो कि होगा 5 upon 13. So the answer is going to be negative 5 upon 13.
Yes.
Okay. Now I want you to try the last part, tan of angle ACD, tangent of angle ACD. So tan of angle ACD, which is an obtuse angle, is going to be equal to negative of tangent of the adjacent acute angle, that is ACB. So tangent of ACB is going to be perpendicular over base or opposite over adjacent. So that is the answer. All right. Any questions, any queries in trig ratios of an acute angle and obtuse angle?
No, sir.
Okay, now there are some trig ratios which you should know. Like the ratio key value should be known by you. So I'm gonna call them special angles. So trig ratios of special angles. Now these special angles are basically angle 30 degree, 45 degree and 60 degree. To remember their trig ratios, you can do the two things. To find the trig ratio of 30 and 60, you can draw an equilateral triangle. Nawal, what is an equilateral triangle?
जिसकी सारी साइड सेम होती हैं,
और सारे angles
इक्वल होता है.
इक्वल होते हैं और उनकी वैल्यू क्या होगी? अगर सारे एंगल्स ट्रायंगल के इक्वल होंगे तो उनकी वैल्यू क्या होगी? If all the angles of a triangle are same, then
60.
each angle is going to be 60 degree.
60.
Right. So each angle is 60 degree. Now I want you to consider this equilateral triangle of side 2 units. If you are going to draw a perpendicular line from the top, would you agree that this perpendicular line is going to bisect this length and it's going to divide the base into 1 and 1?
Yes.
Okay. So this perpendicular line will give you a right angle, a kind of a right angle triangle basically. This is a right angle triangle. Can you help me find this angle? What is this angle going to be? Sorry, the screen is like, just give me a minute. All right.
फिर ऊपर वाले
So
एंगल की तो 30 होगी ना.
yes, this angle is going to be of a value of 30 degrees. Correct. So if I ask you what is sine of 30 degree, cosine of 30 degree, and tan of 30 degree, from the respective right angle triangle that you can see, what is going to be that value? Sine of 30 degree is going to be equal to what, the ratio of which two, like it's going to be equal to the ratio of what? Two sides.
Perpendicular upon hypotenuse.
Perpendicular over hypotenuse. So that is going to be 1 over 2. Cos 30 is going to be equal to
Base upon hypotenuse.
which is equal to, now you need to calculate this side. How are we
Yes.
supposed to calculate this side? Using Pythagoras theorem. So
Yes.
please calculate this side for me using Pythagoras theorem. What do you get? Two square minus one square root. So square root of 2 square minus 1 square is going to give you square root of 3. Are you getting the same value?
Yes.
Now using this, what is going to be the ratio of cos of 30 degree? Cos of 30 degree is going to be the ratio of adjacent over hypotenuse. So it's going to come out as root 3 upon 2. Tan of 30 degree is going to be the ratio of opposite perpendicular यानी कि divided by base or adjacent. So 1 upon root 3. These are the exact values. Even your calculator is going to give you the same exact values. Now the other angle that we can look at is 60 degree K ratios. So sine of 60 degree, for sine of 60 I will have to consider this angle. Sine of 60 degree is going to be equal to opposite over hypotenuse, root 3 upon 2. For cos of 60 degree, it's going to be adjacent over hypotenuse, that is 1 upon 2. And for tan of 60 degree, tangent of 60 degree, that is going to be, what is going to be tangent of 60 degree?
Root 3 upon 2.
Root 3
Root 3
upon 1.
upon 1. Root 3 upon 1.
So that is root 3. Very good. So these are the values that you must remember for special angles such as 30 and 60 degree. And for 45, you can make a square of side 1 centimeter or 1 unit. And if I know that in a square each angle is 90 degree, but if I'm going to divide the square along the diagonal, this angle is going to be bisected and is going to be 45 degree. So I can get my right angle triangle over here. If this length is 1 unit, and this length is 1 unit, what is going to be the hypotenuse? What is going to be the length of the diagonal?
So can you repeat?
In order to find the trig ratio for 45 degree, I'm going to draw a square. You can draw a square and then divide the square along the diagonal length. You're going to get a right angle triangle. Once you have a right angle triangle of this side is 1 and this side is 1, how can you find the length of the diagonal, which is the hypotenuse? To find the length of this diagonal, which is the hypotenuse, you can apply Pythagoras theorem. So 1 square plus 1 square root is going to, square root of the value is going to be, this value is going to come out as square root of 2. Square root of 1 square plus 1 square is square root 2. Now if I ask you what is the ratio of sine of 45, cos of 45 and tan of 45, you can remember, you can find it from here. Sine of 45 is opposite over hypotenuse. So that is going to
1
be
upon
equal to 1
square root
upon root.
2.
Very good. 1 upon square root 2. Cos of 45, 1 upon
1 upon
square root 2.
1 square root 2.
And tan of 45 is going to be the ratio of opposite over adjacent, which is 1 upon 1, hence 1. Now, you
Yes.
can, if you have a calculator with you, you can just find out these values. Your calculator is going to give you the same value. Okay? So these are the trigonometric ratios that you can remember. Now, for how is this going to help us? This is going to help us in questions like these, where the question says find without using the calculator. Find without using calculator the values of the following: a sine of 135 degree, cos of 135 degree, cos of 120 degree, and let's make one more, tan of 150 degree. Okay, so sine of 135 degree. Now, which angle is 135? Is it an acute angle or an obtuse angle? Sine of
Obtuse
130,
angle.
it's an obtuse angle. So sine of an obtuse angle is equal to what? Can I express this sine of an obtuse angle as a trig ratio of an acute angle?
Yes.
So sine of 135 is going to be equal to sine of 180 minus 135, that is sine of 135 should be equal to sine of 180 minus 135. So what is the acute angle equal to? 180
Sine
minus
45.
135? Sine 45. And what was sine 45? If you remember, so you need to do it without the calculator. Sine of 45 is going to be 1 upon square root 2. Similarly, for cos of 135 is an obtuse angle. So to find cos of an obtuse angle, I can represent this as adjacent acute angle, but cos of 135 is equal to negative of cos of acute angle. So what is 180 minus 135? It's 45. So but cos of 135 is going to be equal to negative of cos of 45. And what was cos of 45 degree? It was 1 upon square root 2, right? Cos of 45 was 1 over square root 2. Okay, can I move on?
Yes.
Now cos of 120 degree, again 120 degree is an obtuse angle. So cos of a obtuse angle is equal to negative cos acute angle. What is going to be the adjacent acute angle of 120?
60.
60. And what is cos of 60 degree? What was cos of 60 degree coming out? Cos of 60 degree, you need to remember this, okay,
1
from now on.
upon
So 1
square
upon
root 3.
9, cos of 60 was 1 upon 2.
Oh.
Okay. So cos of 60 degree is 1 upon 2. So cos of 120 is going to be equal to negative of 1 upon 2. Now let's do the last one. Tan of 150 degree is equal to negative tan of an acute angle. Now acute angle of 150 degree is going to be 30 degree. And what was tan of 30 degree coming out? 1 upon root 3. So it's going to be 1 upon square root 3. But tan of 150 का answer is going to be negative of 1 upon root 3. Is that okay?
Yes.
Okay. Now let's consider a triangle. All right. So now we are going to look at this question. Angle ACB is 30 degree, which is this complete angle ACB 30 degree. AD is 2 and BD is 4 centimeter. Without using the calculator, find the length of AC. Okay, you need to find this length of AC. So let me highlight this AC. This is your length AC. How do you plan on finding the length of AC? Any suggestions? To find the length of AC, if you consider this entire triangle ABC, the outer triangle ABC, you know this angle is 30 degree. And what is the length of AB?
6
6
centimeter.
centimeter. Yes. Now, which trigonometric ratio can help me get the length of AC? Which trigonometric ratio can help me find the length of AC? You have this angle, you have the length opposite to the angle, and obviously this length AC is hypotenuse. So which ratio am I going to use for the opposite and hypotenuse?
Sine.
Sine. So in the working, you're going to use sine of 30 degree is equal to opposite over hypotenuse. So AC is going to come out 6 upon sine of 30 degree. Now the question says without using the calculator, so it's going to give me special angles that were 30, 45 and 60. Sine 30 was equal to, if you remember, sine 30 was coming out to be 1 upon 2.
1 upon
So,
2.
so 6 upon 1, 6 divided by 1 upon 2 is 12.
Yes.
So that's your answer. Now for the second part, CE, the length of CE. This is CE. I'm asked to find this length CE. To find this length CE, what you can do is you can first find the length of entire length BC, okay? And then using this inner right angle triangle ABE, you can find BE and then subtract it. Okay, so using the Pythagoras theorem,
पाइथागोरस थ्योरम से हम पूरे ट्रायंगल की ढूंढेंगे ना?
हाँ, तो BC की लेंथ पहले निकाल सकते हैं. सो BC की लेंथ इज गोइंग टू बी स्क्वायर रूट ऑफ 12 स्क्वायर माइनस 6 स्क्वायर. तो ये आपके पास BC की लेंथ आ जाएगी. So 12 square is 144 minus 36. 144 minus 36, 108. So you are going to get square root of 108. I'm going to leave this over here as it is. फिर CE की लेंथ फाइंड करने के लिए what is going to be the length of CE? To find the length of CE, I'll have to find the length of BE. Okay. So I forgot to mention one thing in the question. The length of AB is equal to BE. This is provided in the question. The length of AB is given to you as equal to BE. So BE is equal to AB, that is 6 centimeter.
6 centimeter.
So CE की लेंथ क्या हो जाएगी? CE की लेंथ is going to be square root of 108 minus 6. ठीक है, अब डेसिमल वैल्यू निकाल लो. इसकी इक्विवेलेंट डेसिमल वैल्यू क्या आ रही होगी कैलकुलेटर में? स्क्वायर रूट ऑफ 108 माइनस 6. डेसिमल वैल्यू मेरे पास आ रही है 4.39 से 3
जी
सिग्निफिकेंट.
यार.
ओके. पार्ट सी कह रहा है टेंजेंट ऑफ AEC. So I'm going to mark first the angle AEC, tangent of this angle. Now this is an obtuse angle, as you can clearly see. It's an obtuse angle of AEB. The AEB is going to be an acute angle. So over here we have an acute angle. A tangent of an obtuse angle, tangent of angle AEC, which is an obtuse angle, is equals to minus negative of tangent of acute angle. तो acute angle मेरे triangle में क्या है? AEB. ठीक है नवाल? This is the
जी सर.
acute angle. अब इस acute angle के रिस्पेक्ट से मेरा tan थीटा का रेशियो क्या होगा? tan थीटा का रेशियो होता है perpendicular upon base. So perpendicular की लेंथ माइनस 10 AEB is going to be perpendicular की लेंथ है AB और डिवाइडेड बाय एडजेसेंट या बेस की लेंथ है BE. सो AB की वैल्यू कितनी गिवन है क्वेश्चन में? 6. और BE की वैल्यू क्वेश्चन में
6
कितनी
upon
गिवन है?
12.
6. नहीं,
तो 6 upon 6.
की वैल्यू 6.
Right.
So answer is going to come out as -1. So the ratio comes out to be -1. Now the last part says cos of CAB. Cosine of angle CAB. So let's mark CAB. Angle CAB is over here. This angle. So we know this is a right angle triangle. मुझे cosine मालूम करना है इस angle के respect से. So इस angle के respect से the cosine is a ratio of adjacent upon hypotenuse. So ये AB की जो length है ये मेरी base हो जाएगी इस angle के respect से या adjacent कह लो. और AC is going to be hypotenuse. So with respect to angle CAB, the adjacent is going to be AB. AB की लेंथ क्या है? 6. ठीक है. So 6 upon what is the length of AC in the question?
12.
12. So the ratio is going to come out as 1 upon